Imagine gazing up at the night sky on a crisp July evening, only to realize that somewhere out there hurtling toward our solar system from the vast emptiness between stars is a visitor unlike any we've seen before. Discovered on July 1, 2025 by the Asteroid Terrestrial Impact Last Alert System Telescope in Chile, 3I/Atlas isn't just another comet. It's the third confirmed interstellar object to grace our cosmic neighborhood. And its journey has sparked wonder, debate, and a touch of unease among scientists worldwide. What if this Manhattan-sized wanderer, hurtling at over 137,000 miles per hour, holds secrets about distant worlds, or perhaps something more engineered? Welcome to this deep dive into 3I/ where we'll unravel its anomalies, explore the science behind it, and ponder what it means for humanity's place in the universe. If you're a space enthusiast, a curious student, or just someone who loves a good cosmic mystery, stick around. This story is as thrilling as it gets. Hit that like button if you're ready to blast off, and subscribe for more explorations of the stars. Let's start at the beginning because every great tale needs a solid origin story. Interstellar objects like 3I/ATL are cosmic nomads ejected from their home star systems billions of years ago, drifting through the galaxy until they stumble into ours. The first was 1I/UMUA in 2017. A cigar-shaped enigma that tumbled silently past the sun, defying easy classification with its lack of a comet tail and bizarre acceleration. Then came 2I/Borisov in 2019, more familiar, a comet with a gaseous coma, but still an outsider from afar. Now 3II/Atlas enters the stage, named for its discovery by NASA's Atlas survey, designed to spot potential Earth impactors, but perfectly poised to catch these rare intruders. Picture this. Astronomers scanning the skies for threats, spot a faint dot in the constellation Sagittarius, magnitude 17.5, barely visible even to professional scopes. But as calculations poured in, the truth emerged. This wasn't orbiting the sun like a local. Its hyperbolic path screamed interloper, escaping our star's gravity at speeds too high for anything born here. It's estimated to be at least 5 kilometers across, roughly the size of a major city and 1,000,000 times more massive than Oumuamua. That's not a pebble. That's a behemoth from the stars. What makes 3I/ATL so captivating isn't just its size. It's the parade of peculiarities that have astronomers scratching their heads. From the moment of discovery, anomaly number 1 hit, its trajectory. Most interstellar visitors should barrel in randomly, but 3I/it glides along the ecliptic plane, the flat disk where Earth and the planets orbit the sun, aligned to within 5 degrees. The odds less than 0.2%, 2% or 1 in 500 for a random arrival. It's like a guest showing up exactly on time for a party in a crowded city, threading the needle past Mars at 30 million kilometers on October 2nd, then brushing near Venus and Jupiter. Avi Loeb, the Harvard astrophysicist and head of the Galileo Project, an initiative hunting for extraterrestrial tech, points out in his writings that this precision evokes a designed path. Though he stresses we must gather data before jumping to conclusions. Loeb's voice carries weight here. As author of Extraterrestrial, he's no stranger to bold ideas, but he's grounded in evidence, often drawing from his decades studying black holes and cosmic theory. As summer faded into fall, more quirks surfaced. Early Hubble Space Telescope images from July 21, 2025 revealed an anti-tail, a jet of material pointing toward the sun opposite to the dust tails we expect from comets pushed by solar radiation. This wasn't an optical trick. Side views confirmed it, defying the physics of familiar icy bodies. Then came the composition bombshell. Spectra showed nickel emissions with scant iron, a ratio echoing industrial alloys on Earth, not natural meteorites. Add an unusual polarization, light twisting in patterns unseen in prior comets, and you tally 8 anomalies by September. But the real drama unfolded near perihelion, its closest solar hug on October 29, 2025 at 1.36 astronomical units just beyond Mars's orbit. Observations from NASA's STEREOA, SOHO, and the new GOES-19 satellite caught 3I/Atlas brightening explosively, scaling inversely with distance to the sun's power of -7.5, 7.5 times faster than typical Oort cloud comets. It hit magnitude 9, visible with binoculars, a fireworks display in the inner solar system. And the color, that's where things get truly surreal. As it neared the sun, 3I/Atlas shifted from red to a striking blue, bluer than our 5,800 Kelvin star itself. Dust should rein it, cooling to perhaps 300 Kelvin at that distance. But blue screams high temperatures or exotic emissions, ionized carbon monoxide perhaps, or something hotter like a surface exceeding solar levels. Low in a Medium post from October 30th notes, this could hint at a hot engine, though natural explanations like gas glow aren't ruled out. Compounding the puzzle, the first signs of non-gravitational acceleration, a nudge beyond gravity's pull, reported by NASA's Jet Propulsion Laboratory. For a comet, this might stem from outgassing, ices vaporizing into jets, shedding mass at hundreds of meters/s. Estimates suggest 3I/S could lose 10 to 15% of itself in a month, birthing a debris plume of billions of tons. Yet, no massive tail has fully materialized, leaving room for other ideas. Speaking of which, let's address the elephant, or should I say the spacecraft in the room is 3I/T alien tech. Loeb doesn't shy away proposing a Loeb scale from 0 ordinary comet to 10 maneuvering probe. At Discovery it scored a 4. Post-perihelion anomalies bumped it to 9. He envisions it as a reconnaissance vessel perhaps executing an Earth maneuver, a gravity-assist slingshot around the Sun for speed hidden during conjunction on October 21 when Earth and the object bookend our star drawing from the dark forest hypothesis. A grim solution to FAIR's whereas everybody paradox. Loeb suggests advanced civilizations might lurk silently, sending scouts to young worlds like ours wary of broadcasting their presence. It's a chilling analogy. Imagine the galaxy as a shadowy woods where noise invites predators. But Loeb balances this with rigor. In interviews on News Nation and Joe Rogan's podcast, he emphasizes data over drama, tasking his Galileo observatories to scan for maneuvers or mini-probes. NASA's stance: it's a natural comet per their November 14 FAQ with icy nucleus and CO2-rich coma confirmed by James Webb and SphereX in August. Water ice, carbonyl sulfide, echoes of alien planet formation. No threat, just a gift for study. This brings us to the human drama fueling the chase, the quest for NASA's withheld high-rise images. On October 2, as 3I/Atlas zipped by Mars, the Mars Reconnaissance Orbiter's high-resolution imaging science experiment snapped side shots at 30 kilometers per pixel, 3 times sharper than Hubble's priceless for decoding jets and mass loss. But then the US government shutdown hit on October 1, freezing data pipelines. 43 days later, as of mid-November, those images remain locked despite daily Mars releases on the high-rise site. Loeb's frustration boils over in his writings. Politics sabotaging science when taxpayer-funded data should flow freely within days. The principal investigator, a University of Arizona professor, stays mum. Even Congresswoman Anna Paulina Luna's letter demanding release drew no reply, though acting administrator Sean Duffy tweeted explanations after Kim Kardashian's query, highlighting the absurdity. Loeb clarifies, no cover-up of ET, just bureaucratic folly delaying trajectory tweaks for future probes. As shutdown ends, releases loom, potentially by now, revealing if breakup or intact structure awaits. It's a reminder of our fragile institutions against cosmic time scales. Beyond the intrigue, 3.8 offers profound lessons in astronomy and exploration. Interstellar objects are time capsules flinging materials from other stars. Nickel hints at industrial processes. No, likely primordial, but Webb's infrared scans trace formation in distant disks 4.6 billion years ago. The Vera C. Rubin Observatory in Chile, set to scan the southern sky every 4 nights, promises a new interloper every few months. We'll need protocols like Loeb's risk scale to triage them. Imagine intercepting one. Loeb proposes redirecting NASA's Juno spacecraft with a 2.6 km per second kick near Jupiter on March 16, 2026. When 3/A passes 0.36 astronomical units away, Juno's instruments could sniff composition up close, since launching fresh chasers is impossible against its outbound velocity. This isn't sci-fi. It's feasible engineering, echoing Voyager's grand tour, but inbound for students it's inspiration. Loeb urges curiosity over conformity, sharing how his childhood stargazing birthed a career-challenging norms. Astronauts like those on Artemis missions might one day rendezvous with such visitors, turning detection into direct contact. Of course, myths swirl like comet dust. Common misconception: interstellar equals immediate danger. Truth: 3I/TLAS peaks at 1.8 astronomical units from Earth on December 19, 170 million miles safer than Venus. No collision risk. It's outbound bound for the constellation Leo by New Year's. Another all anomalies scream aliens. As 3I/it fades toward Jupiter and beyond, reaching escape velocity by spring 2026, it leaves us changed. We've glimpsed the galaxy's underbelly, where ejections from trillions of systems pepper space with relics. If natural, it enriches comet lore, urging better models for outgassing in orbits. If engineered a slim black swan per lobe, it rewrites everything demanding vigilance via Galileo-like networks. Like if this sparked your wonder, subscribe for updates and share with a friend. Until next time, keep looking up. The universe is full of surprises. Thanks for joining the journey.